Oh, howdy all, grab yourselves a beer, it is time for some Path of Exile discussion. Have you ever wondered just how likely a time-lost incubator is to grant you a headhunter? Have you ever wondered just how likely an Ancient Orb is to grant you a headhunter? What about a Chance Orb? You ever wondered how many attempts you might need in order to meaningfully collect some data that can help you find out? What I wanted to do with this video is have a look at the way that statistics in games apply. RNG is central to Path of Exile, and it is natural to try to empirically test it and to try to reverse engineer drop rates. Unfortunately, though, statistics aren't well taught at school. So I wanted to go through a few examples of statements that I've seen on Reddit or other places and unpack the maths behind them. But firstly, I want to start with a warning. Mathematical problems that look easy can be very, very, very difficult. You have probably seen mathematical problems on Facebook that have cute little fruits and the like, and that assert 95% of people cannot solve this, and that say, oh, look how hard am I, and then they're usually really easy. So you might think they all are. However, this maths problem here that you see, this sort of fruit math problem, requires machinery that is pretty much exclusive to a small fraction of master's level mathematicians that specialize in number theory. I wrote my honours thesis in the field of number theory, and I discussed the groups of rational points on elliptic curves, which is the machinery that you need to solve this problem. I was still not only was I not able to solve this problem, but I was barely able to follow a written up solution that was done by someone with more knowledge in the field than I have. And the reason that I raise this is to just remind you that many statistical problems are deceptively hard and are very counterintuitive. So the first thing that I want to bring up is the concept of the gambler's fallacy. And this is a common idea that people hold in their minds. And it is the idea that there is some sort of karma to luck. So when I'm talking about karma, what I mean here is the idea that if you have an Exalted Orb drop for you in a map, then that has used up your RNG for the day. Or if you've had a Mirror of Calandra drop for you, or a Headhunter, or something like that, then that's used up your luck for the whole league. And therefore, you should expect to be consistently unlucky for a period of time that balances out the good luck that you've had. However, part of the way that Path of Exile is designed is that events around loot are random. Random means that, importantly, one event doesn't impact others. And the only real random number generation in Path of Exile that isn't random in this way is the rolls for a character to evade attacks. Evasion uses something that is deliberately smoothed out to be less spiky than actual random numbers. And therefore, in that case, the gambler's fallacy does apply. So for evasion, if you take a hit, then it is more likely that the next swing at you will miss. Especially if you've got a good lot of evasion, it may guarantee that the next 2 or 3 are going to miss. However, for random events like opening a barrel and finding an Exalted Orb in it, whether you have opened 600 barrels so far today or none, will have no impact on your probability of getting one on the next time that you open one. There's a couple of other versions of the gambler's fallacy, and I recommend having a read of the Wikipedia page if you're not convinced. But fundamentally, this comes up a lot, and I see it all the time on Reddit. I'm sure some people are just posting comments that fall into the gambler's fallacy to be a bit of a troll and to annoy people like me that have somewhat of a maths background. But I'm sure that there are also many people that sincerely believe it. And a good example of this was an event that happened in the Monte Carlo casino about 100 years ago, where a roulette table spun black something like 25 or 26 times in a row. And as a result, lots of people thought and bet a large amount of money on the streak breaking and it going back to red, because they're thinking, oh, surely after 18 times in a row that it's gone on the black, it's got to be overdue for a red one. And the casino kept taking their bets and kept taking their money, as casinos are designed to do. Lots of people lost a lot of money on that day because they didn't understand the gambler's fallacy. They thought that karma meant that there would have to be more reds to counterbalance the black ones that had already come up. And that was just completely false. So the next point that I want to talk about, though, is the more important one, and that is the question of just how big a sample size do you need in order to reverse engineer drop rates. I wanted to take a couple of the biggest examples that are discussed on Reddit. This one's from 2 years ago from the Harbinger League, and a Redditor by the name of Exiled Angel decided to gamble a lot of currency on Ancient Orbs on unique belts. Now, they got in early on this, and so Ancient Orbs were very, very cheap at this point in the Harbinger League. So they bought many, many thousands of them. And they kept selling the headhunters that they got and gambling on more of them. And they ended up making, making quite a lot of currency out of it. But by the time that they'd used they'd achieved 15 headhunters, they had spent 6,553 Ancient Orbs. Now, the conclusion that they say here, they don't actually conclude that the probability of hitting a headhunter on an Ancient Orb is 1 in 437. They correctly point out that that is the average that they experienced. And then they assert that they think it's about 1 in 400, depends on whether you're lucky or not. What I want to address is this statement here, that it is about, that it's anywhere between 400 and 500 Ancient Orbs on average in order to get a headhunter. And I thought, let's actually pull out a little bit of mathematical machinery and test that statement. What we have here is a spreadsheet that calculates the binomial probability calculator. And what this is, the binomial function is a way of precisely calculating the probability of getting a certain number of successes given a set probability, and making a trial a certain number of times. So here, we're trying 6,553 times to roll a headhunter using Ancient Orbs. We are just going to assert for the moment that it is in fact a 1 in 437 probability, and just see what sort of probability we get for getting exactly 15. And you'll see here that the probability is 10.25%, with a small rounding error. It's also, this second probability here is the probability that you're within 2. So that means within 13 to 17 will be in this row. 15, you're 48% that it's more than 13, that is 13, 14, 15, 16, or 17. And it is 10.25% that it is exactly equal to 15. So that's the probability that when you make 6,553 trials, and each one is 1 in 437, that you'll get exactly 15. So that's a pretty big number. But what if someone else were to come along and say, hey, you know what? Exiled Angel is wrong, and the drop rate is actually 1 in 650. How compelling would the evidence that Exiled Angel has compiled be in defending his position that it is 1 in 437? So let's just assert that the probability is indeed 1 in 650. This means that on average you would only expect to get 10.08 headhunters instead of expecting the 15 that you had before. You'll notice here that the probability is 3.6% of getting exactly 15. That is not small. Given that it was 10.25% before, you'll see that it's still pretty high, your probability of getting 15 when it's 650. So what if we went even further? What if we asserted the probability is actually 1 in 800? And here it's still a 1.06% chance. Now 1.06% is not a lot, but it's also not tiny, especially compared to 10.25. Now it's only a tenth as big. Think 1/10 as big a probability is still very much in the realms of possibility. What if someone else was to assert the actual probability is 1 in 1,000? Now we start to get some more evidence this is looking a bit less likely. We have a 0.2% chance of hitting exactly 15 headhunters if each one is 1 in 1,000. 0.2% is a lot less than 10.25%. It's approximately a 50th of it. And so what we've got here is moderately strong evidence against 1 in 1,000, against the hypothesis 1 in 1,000 is the drop rate of headhunter from Ancient Orbs, as the game was in Harbinger. However, we've only got pretty weak evidence against it being 1 in 650. We've got slightly stronger evidence for it being 1 in 437 or so. What about if we go the other way? 1 in 300, we're still 3%. That's still a quite reasonable chance to, that it is there. 250 is where we'll start finding that it's probability is going down again, 0.6%. Anyways, I have done the numbers so that you don't have to, and I've been able to conclude that assuming that everything Exiled Angel posted in his thread is exactly correct, then there is a 95% chance that the actual probability of getting a headhunter from an Ancient Orb under the conditions of the game back in the Harbinger League was between 1 in 291 and 1 in 697. So rounding off, 1 in 300 to 1 in 700. Notice how wide a range that is. And even then, there is still a 5% chance, because of the sample size that was provided here, there is still a 5% chance that it's outside that. If we're willing to go wider, we can say there is a 99.7% chance that the odds against getting a headhunter are in the range 224 to 1029. But at this point, we're getting to an extraordinarily wide range there. The moral to this story is that actually a large sample size isn't enough. You actually need a relatively large number of successes. Otherwise, you can't make the sort of conclusions that most people drew on Reddit from this thread. And as I said, I'm not having a go at Exiled Angel here because Exiled Angel doesn't assert that it is exactly 1 in 437, but a lot of people, read into this thread. I've seen it referenced several times and assert that actually 1 in 437 is correct. This is even more true when we talk stacked decks. And I ran a little bit of an experiment where, because several content creators have opened 10,000 stacked decks, and it seems plausible, it's certainly not proven, but it seems somewhat plausible from their data that the probability of getting a House of Mirrors divination card is 1 in 5,000 from a stacked deck. Now, let's say that I think it's 1 in 5,000 and that you, the listener, think that it's 1 in 6,000 to get a stacked deck. How many stacked decks would you need to open in order to prove one or both of us wrong? And it turns out that you actually would need to open more than 1 million. Otherwise, even if I'm correct and it is in fact 1 in 5,000, in order for the sample size to be large enough to rule out 1 in 6,000, to render that, to render the probability of getting 1 in 6,000 close to 0, you would actually need to do more than 1 million stacked decks in order to achieve that goal. So that is the first thing that I want to make. Sample sizes need to be a lot bigger than people intuitively think. Now, the second point that I want to make is a term that is called reporting bias. Reporting bias, and there's a good page on this on Wikipedia, is another thing that comes up a lot when you're trying to reverse engineer drop rates in a game. And what this is that players feel more compelled to talk about events that they personally feel are remarkable. So, let's imagine that there are 200 players that each crack open that each take the time lost incubators. So these add a random time-worn unique item to, and basically you incubate it, but once the incubator hatches, you will then be rewarded with a time-worn unique. Time-worn uniques are ones that can't drop under normal game mechanics. Most of them are rubbish, but some of them include things like the very, 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 very valuable headhunter. And so, 200 individual players each purchase 5 of these, and each hatch them. One of them wins the lottery and gets a headhunter. That player is super excited. They make an excited Reddit post about it because it's the first time they've ever had a headhunter. It feels like they're going to have the most amazing league ever because they've got this mythical item that they could never afford before. They go out and they tell all their friends, hey, you should go and buy these time lost incubators because I got a headhunter from one. Another person doesn't get quite so lucky. What they get is a bunch of the same unique item. They get 3 copies of the unique ring Telesos sign, which isn't particularly valuable, but they think it's a really remarkable result because, 3 copies of the same unique ring They all pop at the same time. There's this fantastic screenshot that they take where there's the 3 Telesos signs all on the ground, as well as 2 other unique items that they don't really care about. So they take a screenshot of that and they post it to Reddit as well. Really excited and somewhat disappointed that, because, again, gambler's fallacy, they feel like they have wasted all of their RNG for the league on this fluke event that didn't actually have any payoff for them. So they then go and make an excited Reddit post. The other 198 players hatch their 5 time lost incubators and get basically nothing from them. Some of them do make the money back. They get one of the mid-tier uniques, like 7 league steps, but others of them, it's not so remarkable they feel a need to brag about it. And others go, oh, damn, I just got five junk uniques, and there goes 100 Chaos Orbs that I could have spent on something much better. So what happens if you're an observer that's watching these events unfold? Well, you're watching on Reddit. You don't notice the 198 people that cracked their 5 time lost incubators and didn't bother reporting their results because they didn't feel they were remarkable. However, you do see 2 reports go up. One of them, I bought 5 time lost incubators and I got a headhunter. The other one, I bought 5 time lost incubators, didn't get a headhunter, RIP me, but look at this. And they show off their 3 Telesos signs. And this is the problem of reporting bias. You need to find a way to counteract that if you're going to make any sort of attempt to reverse engineer drop rates. One way you can do this is to actually run everything yourself. So, if you wanted to ascertain the probability of getting, say, the Scourge unique claw from the Guardian of the Chimera, you could run 500 Guardian of the Chimera maps and 500 Pit of the Chimera maps, and then amass your results, and then make some sort of estimate. Use statistical techniques to determine a 95% confidence interval, and then report your findings. And maybe you'll say, okay, I ran 500 Pit of the Chimera, I got 37 of this unique item, therefore I conclude that the drop rate is between 6% and 9% with a 95% likelihood. Actually, it'd be a wider confidence interval than that. Without actually running the numbers myself, it might be between 5% and 10% from that information. The sample size isn't very big, even though it is 500 maps. But you're hitting a problem here where 500 maps is a lot to run yourself already. You would want to, if you wanted to do a more serious test of this hypothesis that the probability of getting the Scourge Claw is about 7.5%, you're going to need to run a lot more maps than just 500. And so you're going to need to get other people involved. The key thing you need to do, and there's only one content creator that does this well, and that's Slippery Jim. The key thing that you need to do is to line up a bunch of people to all run a certain amount of maps, and they need to report to you no matter what. They need to report to you if they feel like they were lucky, they need to report to you if they feel like they were unlucky, and they need to report to you if they feel their results were unremarkable. You then need to chase every single one of them up yourself. And that's actually quite difficult to do. It's very difficult to organize because flaky people can really, really ruin your results. So it is very difficult to counter both the small sample sizes and reporting bias in order to reverse engineer drop rates. It's not easy at all, and there's very little that can actually be said about drop rates in this game without going to the massive distributed efforts like Slippery Jim's 10,000 burial chambers map results that were done several leagues ago, and so unfortunately aren't particularly relevant anymore. I also want to talk about the darker side of reporting bias. There are certainly ways that you can manipulate reporting bias in your favor. If you are an unethical content creator and trader, what you can do is you can take a very high variance piece of crafting currency like this enchanted fossil here, or alternately a very high variance item like some of the incubators. Thaumaturge's incubator is another example of a high variance currency item. Or skittering incubators, these are another one. Skittering incubators are very high variance. And the unethical approach to using these is to buy up a couple of thousand of whatever item that you're trying to abuse. Then record about 10 different videos where you turn in 20 of them at a time. So let's take one thing that you could use for this would be divination cards. Arrogance of the Vaal. Arrogance of the Vaal is a divination card, set of 8 for a 2 implicit corrupted unique item. Very high variance on this. Most unique items are trash and 2 implicit corruptions don't get them over the line to being useful. However, there's a number of things that you can hit with this that are truly, truly amazing. And an unethical person could buy 100 sets of this to turn in, plus 1,000 sets to resell later. With that 100 sets, you're going to turn them in. Turn them in 10 at a time as separate videos. Record them each time, and just the best one, or the best 2 of them, upload them to YouTube or Reddit or Imgur or wherever you want to upload them, and then draw some attention to them, to your staggeringly good luck that you've had. While when there's a whole lot of excitement around the card and people feel that because of the reporting bias you're inducing by only reporting your best results, because of that reporting bias, you then sell off all of your remaining cards at a steep markup. I've actually unintentionally done this. I've certainly never done these sorts of unethical trading strategies in this game, but I've unintentionally done this with Enchanted Fossils in the past, where I posted a video showing how I would craft with Enchanted Fossils. I didn't get staggeringly lucky, but I got a number of sellable results from it. And then I wound up some days later, because I bought too many Enchanted Fossils for the video, I wound up some days later with someone buying all of my leftovers at twice the price that I'd paid for them. Now, I didn't do that deliberately, but it's certainly something that someone unethical can abuse. So in conclusion, statistics is harder than it looks. It is deceptive. Things that look trivial are often not so, and you want to keep that in mind all of the time. A lot of the things that feel intuitive about random number generation are wrong, and the gambler's fallacy is a great example of this. You want to always be conscious of that, and remember, just because I've had an unlucky streak doesn't mean I'm due for a lucky streak. Just because I've had a lucky streak doesn't mean I'm due for an unlucky streak, nor does it mean that my lucky streak will continue. Your past results have no bearing on your future outcomes. And so yeah, there's these statements about random number generation. Secondly, that sample sizes that you need to reverse engineer drop rates are much bigger than you might intuitively think. And you can prove this to yourself by running a spreadsheet with a binomial probability generator. Lastly, reporting. Always be conscious of reporting bias. Whenever you see reports of good luck or bad luck on Reddit, take it with a grain of salt. And remember that players will only report things that sound truly exciting or interesting or unusual to them. Anyways, I'm going to open this up for questions. If you've got any questions, comments, or the like, if you think I'm mad, then definitely comment below and let me know what you think.